Okay, this is chapter 10, number 57a. We have two spheres, and they're connected by a rod that's, I believe, massless. Connected by a thin, massless rod of length r. So the rod is length r, and that's also true of the radius of each thing. Each sphere has a radius of r. So altogether it's 3r from center of mass here to center of mass here. So in order to figure out what the total inertia is, we need to find the inertia of this part, which I drew over here, and add that to the inertia of this part, which will be the same thing. So the total inertia will equal inertia 1 plus inertia 2. And since 1 equals inertia 2, the total inertia will be 2I of whatever this is. Okay. So, how do we find this inertia? We use the parallel axis theorem. Parallel axis theorem says that to find the inertia, you take the inertia of center, the moment of inertia, center of mass, plus mh squared. So the moment of inertia of the center of mass is saying that we should draw a line that's parallel to the axis of rotation, which is the green line here. Rotates about the green line axis. So there's our parallel line, and it goes through the center of mass. Now if it were to rotate around this axis, what would be its inertia? Well, that would be the inertia of the sphere. So IM, or ICM, equals the inertia of a sphere, moment of inertia of a sphere, which is 2 mr squared. Next is find this. Well, mh squared is m, and h is the distance from one axis to another. So this is h. Okay. So h will be r plus 1/2 r. So that's 3/2 r. Halves r. That whole thing is squared. So that's 9/4 mr squared. Okay, next is to put it up, and I'll be right back. Hello. I just paused it. Sorry. Alright, so the total inertia, or the inertia for this part, will be for the center of mass. Come on, draw. There it goes. Okay. Is 2/5 mr squared plus mh squared, which is 9/4 mr squared. So on the side, 2/5 plus 9/4 equals 8/20 plus 45/20 which equals 53/20. Okay, so I equals 53/20 mr squared. Then looking at what the total is times 53/20 mr squared, which equals 5 3/10 r squared. There's your answer.